North Atlantic, 400 miles east of Iceland. The Soviet Alfa-class submarine K-123 cruised at 150 meters depth when the sonar operator's headphones crackled with the distinctive ping of active American sonar. Captain Second Rank Yuri Kalinichenko ordered immediate evasive action without hesitation. Emergency power to the main reactor. All ahead flank. The titanium-hulled submarine accelerated through the dark waters like nothing else that had ever operated beneath the ocean surface. 43 knots. The fastest submarine speed ever achieved in combat conditions. The liquid metal-cooled reactor poured energy into the propulsion system as K-123 fled south toward the Greenland-Iceland-UK gap. Soviet doctrine was clear. American submarines were quiet but slow. Sprint at maximum speed and no American boat could maintain contact. The pursuit would end within hours as the Americans fell behind, unable to match Soviet engineering. But 80 miles behind K-123, USS Dallas maintained perfect sonar contact. The Los Angeles-class attack submarine followed at just 25 knots, nearly half the speed of the fleeing Soviet boat. Commander Daniel Jones studied the waterfall display as his sonar team tracked every sound emanating from the Soviet submarine. The faster K-123 ran, the louder it became. Propeller cavitation, machinery vibration, water flow turbulence across the titanium hull. The acoustic signature was unmistakable. Contact bearing constant, the sonar supervisor reported. Range opening slowly, but signal strength actually increasing. Target making enough noise for the entire Atlantic fleet to hear. Captain Kalinichenko would run his submarine at emergency power for 12 hours before Soviet doctrine forced him to slow. By then, his crew would be exhausted, his fuel reserves depleted by a quarter, and the American submarine would still be there. 70 miles behind, tracking perfectly, waiting patiently. The Soviet captain understood the implications immediately. The Alfa-class submarine represented the pinnacle of Soviet naval engineering, the fastest underwater vessel ever built. But speed couldn't save you when the enemy heard you coming from beyond the horizon. For the Soviet Union, the Alfa-class submarine represented revolutionary thinking about underwater warfare. Traditional submarine doctrine emphasized stealth and patience. Soviet engineers chose a different path: overwhelming speed that would render enemy pursuit irrelevant. Project 705 Lyra, NATO designation Alpha, began development in the early 1970s as the Soviet answer to American submarine technology. Admiral Sergei Gorshkov, Commander-in-Chief of the Soviet Navy, demanded a submarine that could sprint away from any threat. American submarines were becoming quieter. American torpedoes were becoming faster. Soviet boats needed an escape mechanism that no enemy could counter. The solution was titanium. While Western submarines used steel pressure hulls limited to depths around 1,000 feet, Soviet metallurgists had mastered titanium fabrication. Titanium offered strength-to-weight ratios that steel couldn't match. An Alpha-class submarine could dive beyond 2,000 feet, deeper than American torpedoes were optimized to operate. Crush depths that would destroy Western boats were routine operating parameters for Soviet Alphas. But titanium presented extraordinary challenges. The metal was difficult to weld, requiring specially trained workers and controlled atmospheric conditions. Contamination during fabrication could create weak points that would fail catastrophically under pressure. The entire Soviet titanium submarine program was classified above top secret. Only 3 shipyards in the Soviet Union possessed the capability to work with titanium pressure hulls. The reactor represented even more radical innovation. Conventional nuclear reactors used pressurized water coolant, requiring heavy pumps and extensive shielding. Soviet engineers designed a liquid metal-cooled reactor using lead-bismuth eutectic. The system was compact, powerful, and enabled the small hull size that contributed to the Alpha's speed. The reactor could generate enough power to push the 2,800-ton submarine to 43 knots submerged. For comparison, American Los Angeles-class submarines displaced 7,000 tons and could reach 25 knots maximum. The Alpha was lighter, faster, and could dive deeper than anything the United States Navy operated. Automation reduced crew requirements to just 31 sailors, compared to over 100 on conventional Soviet submarines. Computer systems managed reactor operations, ballast control, and damage assessment. In Soviet doctrine, this meant each Alpha-class submarine required fewer trained personnel, enabling the Navy to operate more boats with existing manpower. The armament was secondary to the mission. 6 533mm torpedo tubes in the bow carried a mix of Type 53 torpedoes and anti-ship weapons. But the Alpha wasn't designed to hunt American submarines or surface ships. The mission was simpler: detect enemy forces, gather intelligence, and escape before being engaged. Speed was survival. 7 Alpha-class submarines entered service between 1971 and 1981. K-64, K-123, K-316, K-377, K-432, K-493, and K-508. Each cost approximately 3 times as much as a conventional Soviet attack submarine. Admiral Gorshkov defended the expense to Soviet leadership. The Alpha represents the future of submarine warfare. When speed dominates, American technological advantages become irrelevant. Soviet confidence in the Alpha-class was absolute. American submarines were quieter, but quiet submarines still moved at conventional speeds. The Mk-48 torpedo, standard American submarine weapon, could reach 35 knots maximum. The Alpha, at 43 knots, could simply outrun American torpedoes. American submarines launching attacks would find their weapons chasing an opponent that pulled away at 8 knots of speed advantage. Soviet naval exercises demonstrated the doctrine repeatedly. Alpha-class submarines detected mock enemy contacts, sprinted away at maximum speed, and escaped simulated attacks. No Soviet submarine could catch them. No Soviet torpedo could catch them. American submarines would face the same physics. But American submariners were preparing different tactics. The USS Dallas, pennant number SSN 700, commissioned in July 1981 as the 9th Los Angeles-class fast attack submarine. Commander Daniel Jones took command in 1984 with orders to patrol the Greenland-Iceland-UK gap and track Soviet submarine activity. The Los Angeles-class represented American submarine doctrine at its most refined. Where Soviet engineers chose speed, American designers chose stealth. Where Alphas prioritized escape, Los Angeles-class submarines prioritized detection and tracking. The fundamental philosophy was simple: find the enemy first, maintain contact, control the engagement geometry, and strike only when victory was certain. SSN 688 Los Angeles measured 360 feet in length and displaced 7,000 tons submerged. The S6G pressurized water reactor produced 35,000 shaft horsepower, enough for 25 knots sustained underwater speed. Maximum diving depth was approximately 950 feet. On paper, the Los Angeles appeared inferior to the Alpha-class in every performance metric except endurance. But the Los Angeles possessed capabilities that didn't appear in speed specifications or diving depth charts. The AN/BQQ-5 sonar suite represented the most sophisticated underwater detection system ever installed in a submarine. Passive sonar arrays covered the bow in a spherical configuration capable of detecting submarines at ranges exceeding 100 miles in favorable acoustic conditions. The system could distinguish individual submarine signatures based on propeller blade count, machinery vibration patterns, and reactor cooling pump frequencies. A towed array sonar, designated SIRTAS, extended behind the submarine on a cable that could reach 2,600 feet in length. Operating far behind the submarine's own noise signature, the towed array detected low-frequency sounds that traveled hundreds of miles through ocean thermal layers. Soviet submarines that believed they were operating undetected often appeared on American towed array displays before they'd traveled 50 miles from port. The combat system integrated passive sonar, active sonar, weapons control, and navigation into a unified tactical picture. Fire control computers could track multiple targets simultaneously, calculate firing solutions, and guide torpedoes via thin wires that unreeled from the weapon as it traveled toward the target. The Mk-48 AD-cap torpedo could be launched, guided remotely by the submarine's sonar operators, and directed onto targets that the torpedo's own sensors couldn't detect. But the most important advantage was acoustic stealth. Los Angeles-class submarines were designed from the pressure hull outward to minimize noise. 7-bladed propellers reduced cavitation. Machinery mounted on rubber isolation systems prevented vibration from reaching the hull. Anechoic coating absorbed enemy sonar pulses instead of reflecting them. Every component was selected, designed, and installed with one goal: operate silently enough that enemy submarines couldn't detect you until you were already in attack position. The crew of 133 officers and enlisted sailors trained constantly. American submarine commanders emphasized 3 skills above all others: passive sonar operation, quiet ship procedures, and contact tracking. Sonar operators learned to identify individual submarines by their unique acoustic signatures. Entire crews practiced maintaining stealth during high-speed maneuvers. Every sailor understood that noise meant detection, detection meant engagement, and engagement meant potential death. The Los Angeles could sprint at 25 knots when necessary, but operational doctrine emphasized patience. Move slowly and quietly. Listen constantly. Detect the enemy before they detect you. Speed was a resource to be conserved and used only when tactical advantage demanded it. Commander Jones had read the intelligence reports on Soviet Alfa-class submarines: titanium hulls, deep diving, 43 knots. The specifications were impressive. But Jones had also read the acoustic analysis reports. Alfa-class submarines were loud. The liquid metal reactor required powerful coolant pumps. The high speed created propeller cavitation and flow noise. The small crew size meant reduced damage control capability and maintenance oversight. Soviet engineers had built the fastest submarine in the world. American engineers had built the quietest. The North Atlantic would determine which philosophy was correct. The encounter between USS Dallas and Soviet Alfa-class submarine K-123 began 400 miles east of Iceland on a grey March morning in 1985. Dallas was conducting routine patrol operations, moving south at 8 knots at a depth of 400 feet. The towed array sonar was deployed 2,000 feet behind the submarine, listening to the ocean. At 0843 hours, sonar technician First Class Michael Rodriguez detected a faint contact on bearing 037, range estimated at 80 nautical miles. The signature was distinctive: high-frequency machinery noise, propeller blade count consistent with Soviet design, reactor coolant pump frequency, matching known Alpha-class characteristics. Rodriguez pressed the intercom button. Con, sonar. New contact, designated Sierra 12, bearing 047, classified possible Alpha-class submarine. Contact is weak, but confidence is medium-high based on acoustic signature. Commander Jones arrived in the sonar room within 2 minutes. He studied the waterfall display as the sonar computer analyzed the audio data. The signature was unmistakable: Alpha-class, the first one Dallas had encountered on this patrol. Maintain passive track, Jones ordered. Plot course and speed. I want to know where he's going. For 3 hours, Dallas followed K-123 without being detected. The Soviet submarine was moving northwest at approximately 12 knots, probably conducting a patrol transit toward the Norwegian Sea. The American submarine maintained 80 miles separation, well beyond the range where Soviet sonar could detect the quiet Los Angeles-class boat. Jones reviewed his tactical options. He could maintain passive track indefinitely, gathering intelligence on Soviet patrol patterns and operating areas. He could close the range and conduct a closer inspection, risking detection but obtaining better acoustic data. Or he could deliberately provoke the Soviet submarine to observe its evasive tactics. The intelligence value of seeing how an Alpha-class submarine responded to detection was significant. American attack submarine commanders needed to know if Soviet training matched the theoretical capabilities of their boats. Jones made his decision. Sonar con, prepare to go active, single ping, maximum power. At 11:47 hours, USS Dallas transmitted a high-power active sonar pulse directly at K-123. The acoustic energy traveled through 80 miles of seawater in approximately 2 minutes. On K123, the sonar operator's headphones exploded with the characteristic sound of American AN/BQQ-5 active sonar. Captain Kalinichenko's response was immediate and exactly according to Soviet doctrine. Emergency power. All ahead flank. Course change to 180 degrees. Dive to 400 meters. The titanium-hulled submarine accelerated through the thermal layers as the liquid metal reactor poured energy into the propulsion system. 35 knots, 40 knots, 43 knots, maximum. The Alfa-class submarine fled south at the fastest underwater speed any submarine had ever achieved in combat conditions. On USS Dallas, Rodriguez watched the Soviet submarine's acoustic signature intensify dramatically. Sonar. Contact Sierra 12 has increased speed to approximately 40 knots. Bearing is now 043 and opening. Contact has increased depth. Noise level has increased 25 decibels. We have constant sonar contact with high confidence. Jones nodded calmly. Helm. Increase speed to 25 knots. Maintain course to intercept. We're going to follow him. For the next 12 hours, USS Dallas followed K123 south through the North Atlantic. The Soviet submarine maintained maximum speed, changing course periodically, but never slowing below 40 knots. The American submarine followed at exactly 25 knots, maintaining perfect sonar contact at ranges varying between 60 and 90 miles. The physics of underwater acoustics were unforgiving. The faster K123 moved, the more noise it generated. Propeller cavitation created bubble clouds that reflected sonar pulses. Water flowing across the hull at high speed generated turbulence. The machinery inside the submarine vibrated at higher frequencies. Every component that moved created sound, and sound traveled efficiently through seawater. Rodriguez could identify specific machinery systems on K123 based on their acoustic signatures. The main coolant pumps operated at a distinctive frequency. The reduction gears connecting the reactor to the propeller shaft created harmonics. Even the flow of liquid metal coolant through the reactor's primary loop was audible at close range. Sonar, Rodriguez reported at 1830 hours. Contact Sierra 12 has maintained 40+ knots for 6 hours. Noise signature indicates extreme machinery stress. Estimate contact will need to reduce speed soon for operational safety. Jones studied the tactical plot. K123 had covered nearly 250 nautical miles at high speed, burning through fuel reserves at an unsustainable rate. The Soviet crew would be exhausted from constant high-speed maneuvering. Machinery would be approaching maintenance limits. The American submarine was still there, following patiently, never losing contact. At 23:15 hours, K123 reduced speed to 15 knots. The acoustic signature decreased immediately as propeller cavitation ceased and machinery vibration diminished. But USS Dallas maintained perfect contact. The Soviet submarine was now just 70 miles ahead, moving slowly enough that Dallas could close the range if ordered. Captain Kalinichenko understood the tactical situation immediately. His submarine had fled at maximum speed for 12 hours. The American boat was still there, still tracking, still in perfect attack position. Speed had not provided escape. The most advanced capability of the Alfa-class submarine had failed to defeat American tracking. The implications were devastating. Soviet doctrine assumed that Alfa-class submarines could sprint away from any threat. But sprinting created so much noise that American submarines could track them from extreme ranges. The tactical advantage of speed was completely negated by the acoustic disadvantage of noise. USS Dallas maintained contact with K123 for another 8 hours as the Soviet submarine proceeded slowly toward the Barents Sea. Jones transmitted detailed acoustic data back to Submarine headquarters via extremely low-frequency communications. American intelligence would analyze every aspect of the encounter, building a complete picture of Alfa-class capabilities and limitations. At 0800 hours the following morning, K123 crossed into Soviet territorial waters north of Murmansk. USS Dallas broke contact and turned west to resume patrol operations. Commander Jones entered the encounter in the patrol report with a simple conclusion: contact maintained continuously for 20 hours. Target speed advantage provided no tactical benefit due to acoustic signature increase. Los Angeles-class capabilities confirmed superior for tracking and engagement. The encounter was not unique. Similar incidents occurred throughout the 1980s as American Los Angeles-class submarines encountered Soviet Alfa-class boats in the North Atlantic, Norwegian Sea, and Mediterranean. The pattern was consistent. American submarines detected Soviet Alphas at long range, maintained passive contact, and could follow indefinitely regardless of Soviet speed. In 1987, USS Philadelphia tracked an Alpha-class submarine for 36 continuous hours as the Soviet boat transited from the Barents Sea to the Mediterranean. The Soviet submarine attempted multiple evasion tactics, including high-speed sprints, emergency depth changes, and course reversals. Philadelphia maintained contact throughout every maneuver. The acoustic advantage was insurmountable. The torpedo equation was equally problematic for Soviet doctrine. Alpha-class submarines assumed they could outrun American Mk-48 torpedoes, which had a maximum speed of 35 knots compared to Alpha's 43 knots. But this analysis ignored weapon range and guidance systems. The Mk-48 AD cap torpedo had an effective range exceeding 30 nautical miles when wire-guided by the launching submarine. An American submarine could detect an Alpha at 80 miles, close to 40 miles while remaining undetected, and launch torpedoes that would cover 30 miles to target. The Soviet submarine would detect the torpedo launch and flee at 43 knots. But the torpedo didn't need to chase at maximum speed for the entire distance. The Los Angeles-class submarine maintaining sonar contact could guide the torpedo onto the most efficient intercept course via the thin wire connection. The torpedo could run at 35 knots while the Alpha sprinted at 43 knots, but geometric calculations favored the weapon. Launching from 40 miles and guiding toward a fleeing target at 43 knots, the Mk-48 would reach firing range within minutes. The 8-knot speed advantage meant nothing when the weapon started 40 miles closer than the Alpha assumed possible. American submarine commanders practiced these attack geometries constantly. Fire control computers could calculate intercept solutions automatically, factoring in target speed, torpedo speed, wire guidance updates, and acoustic conditions. Soviet Alpha crews trained to flee at maximum speed. American Los Angeles crews trained to launch from positions where flight was already too late. Deep diving provided limited advantage. Alpha-class submarines could reach 2,000 feet depth, far beyond the 950-foot capability of Los Angeles-class boats. But sonar worked at all depths. Towed arrays could detect submarines regardless of depth. American torpedoes could engage targets at 2,000 feet by diving at steep angles. The depth advantage created tactical options, but not immunity. The fundamental problem facing Soviet Alpha-class submarines was immutable physics. Submarine warfare was acoustic warfare. The submarine that detected first usually won. Speed was irrelevant if the enemy already knew your location. Los Angeles-class submarines operated so quietly that Soviet sonar systems couldn't detect them until ranges under 20 miles in ideal conditions. By that point, American submarines had already been tracking the contact for hours. The American boat was already in attack position. The Soviet submarine was already targeted. Speed couldn't save you from an opponent you didn't know existed. The liquid metal reactor, initially touted as revolutionary technology, created operational nightmares. Lead bismuth eutectic coolant had to remain above 123 degrees Celsius to stay liquid. This meant the reactor could never be shut down completely, even when the submarine was in port. Constant heating was required to prevent the coolant from solidifying, which would destroy the reactor. Several Alpha-class submarines suffered reactor casualties that sidelined them for months. K-377 experienced coolant solidification in 1982 that required the entire reactor to be cut out and replaced. K-123 suffered a reactor accident in 1982 that killed 3 crew members and contaminated sections of the submarine with radioactive lead bismuth. The high-performance reactor that enabled 43-knot speed was maintenance-intensive, dangerous, and expensive to operate. Automation reduced crew size to 31 sailors, but this created vulnerabilities. Damage control required multiple people working simultaneously. Maintenance required expertise across multiple systems. Combat operations demanded personnel to man sonar, weapons, navigation, and command positions simultaneously. The small crew was adequate for routine operations, but inadequate for emergencies. American Los Angeles-class submarines carried 133 officers and enlisted sailors. This created redundancy in critical positions, enabled comprehensive maintenance schedules, provided depth in damage control teams, and allowed sophisticated watch rotations that kept crews fresh during extended patrols. The larger crew was an advantage, not a limitation. Soviet doctrine had assumed that American submarines would be unable to track Alpha-class boats effectively. The assumption proved catastrophically wrong. Post-Cold War analysis by Russian naval historians revealed that American submarines detected Soviet Alphas in virtually every encounter. The speed advantage provided no tactical benefit because acoustic signatures increased proportionally with velocity. Titanium hull construction, while impressive engineering, provided marginal tactical advantage at enormous cost. Each Alpha-class submarine cost approximately 3 times as much as a conventional steel-hulled attack submarine. The Soviet Union built 7 Alphas when the same resources could have built 21 conventional boats. From a fleet perspective, the investment was questionable. American Los Angeles-class submarines, in contrast, were designed for mass production. Standardized components, proven reactor designs, conventional steel hulls, and streamlined construction techniques enabled the United States Navy to build 62 Los Angeles-class submarines between 1976 and 1996. The class represented the most successful attack submarine design in naval history, measured by total numbers built, operational effectiveness, and combat capability. Soviet submariners came to dread encounters with American boats. The Americans were invisible. They detected you first. They tracked you continuously. And if war came, they would launch weapons before you knew they were there. Speed couldn't defeat invisibility. The final Alpha-class submarine, K-493, was decommissioned in 1996. The liquid metal reactors were too expensive to maintain. The titanium hulls were too specialized to repair. The tactical doctrine had been proven obsolete. 7 submarines that represented the pinnacle of Soviet submarine engineering were scrapped within 25 years of entering service. USS Dallas served from 1981 to 2018, a 37-year operational career. The Los Angeles class as a whole served from 1976 until the 2020s, with some boats still in active service as late as 2025. The durability, reliability, and effectiveness of the design validated American submarine doctrine completely. Modern Russian submarines reflect the lessons learned from the Alpha-class experience. The Akula-class and Yasen-class submarines emphasize acoustic stealth over raw speed. Maximum speeds are in the 25-30 knot range, comparable to American boats. Conventional pressurized water reactors replace liquid metal coolant systems. Larger crews enable better damage control and maintenance. The fastest submarine ever built taught the Soviet Union that speed alone doesn't win underwater warfare. American submarine doctrine remains unchanged. Detect first, track continuously, maintain acoustic advantage, control engagement geometry. The Virginia-class submarines replacing the Los Angeles-class are even quieter, with improved sonar systems and more sophisticated weapons. Speed specifications remain modest at 25 knots. American submariners learned the correct lesson. Stealth, sensors, and tactics defeat speed. The physics of submarine warfare are unforgiving. Sound travels at 4,800 feet per second through seawater. Sonar detects submarines by listening for sounds they cannot avoid making. Propeller noise, machinery vibration, flow turbulence. The quieter submarine detects the louder submarine first. Detection range determines who controls the engagement. Speed is meaningless when your opponent hears you coming from 80 miles away. Soviet Alfa-class submarines represented extraordinary engineering achievement. Titanium pressure hull fabrication required industrial capabilities only the Soviet Union possessed at scale. Liquid metal-cooled reactors demonstrated innovative thinking about compact nuclear power. 43 knots underwater speed remains unmatched by any submarine before or since. The technical accomplishments were remarkable, but technical achievement doesn't guarantee tactical effectiveness. The Alfa-class was built to flee from American submarines. The problem was that American submarines detected Alphas before the Soviets knew anyone was there. By the time a Soviet captain ordered emergency power and maximum speed, the American boat had already been tracking him for hours. Commander Jones summarized the tactical situation in his patrol report. Contact attempted evasion at speeds exceeding 40 knots. USS Dallas maintained continuous sonar contact at ranges between 60 and 90 nautical miles. Target speed advantage provided no escape capability due to increased acoustic signature during high-speed transit. Assessment: Los Angeles-class capabilities superior for detection, tracking, and engagement, regardless of target speed. The Soviet Union built the fastest submarine in history. The United States built the quietest. In the underwater warfare of the Cold War, quiet defeated fast every time. 7 Alfa-class submarines fled through the North Atlantic at 43 knots, titanium hulls diving deep, liquid metal reactors at emergency power. Behind them, American Los Angeles-class submarines followed at 25 knots, maintaining perfect contact, tracking continuously, waiting patiently. The Soviets had built submarines to escape. The Americans built submarines to hunt. Soviet submariners discovered that you cannot outrun what you cannot hide from. Speed created noise. Noise enabled detection. Detection meant being tracked continuously by an enemy you couldn't see, couldn't hear, and couldn't shake, no matter how fast you ran. The Soviet Navy planned to fight the underwater war of 1965, when submarines were loud and speeds were slow and detection ranges were short. America fought the underwater war of 1985, when passive sonar could hear a submarine from beyond the horizon and acoustic stealth rendered speed advantages meaningless. In the depths of the North Atlantic, the fastest submarines ever built fled at record speed from enemies they never saw, and their speed saved no one.